So the topic that we are going to do today is spherical mirrors. So what is a spherical mirror? A reflecting surface which is part of a sphere. That is why we call it as a spherical mirror. So circular ball, out of that a glass ball, you can cut down two pieces and paint from one side, just like how we paint the plane mirror similarly. So if I paint this much part of the glass sphere, see once again. So the part which is not painted is called as a reflecting surface, and the other part is called as a painted surface. Rays of light are going to be incident on the reflecting surface. This is called as convex mirror, and this one is called as concave mirror. Same thing, showing you once again the spherical surface. Out of that, this much part we have taken, the remaining part I have shown you in dotted lines. So this is convex mirror. This part of the convex mirror we call it as reflecting surface, or also called as incident surface. The inner one where we have painted, we call it as painted surface. Few more terms. This horizontal line passing through the center of the sphere is called as principal axis, and this dot we call it as center of circle, but now in this chapter we are calling it as center of curvature. This red colored dot, which is marked as capital P, this is called as pole. It is the center of the mirror, not the entire sphere. This is the center of the part of the mirror that we have cut, we are considering, and it should lie on the principal axis. The distance PC is called as the radius of the circle. So here we will call it as radius of curvature. Same terms we'll be using in case of concave mirror also. The reflecting surface, painted surface, horizontal line called as principal axis, center of curvature, that is the center of the sphere, center of the mirror is called as pole, and the distance PC we mark it as radius of the circle. Here we call it as radius of curvature. Once again, this is concave mirror and this is the convex mirror. The plane surface area through which the rays of light enter, or the surface area which is exposed to light, on which the light is going to be incident, is called as aperture. Now if you remember how a ray of light passes through plane mirror, we used to draw an incident ray, then we used to draw a normal perpendicular at the point of incidence. Similarly here also I'm going to show you right now how a ray of light passes through concave mirror. Say for example, AB is an incident ray. Okay, now the question arises, how do we draw a normal for a curved surface? The process is to draw a tangent at point B and then draw 90 degrees on it. What is this tangent and all? Okay, so you don't have to worry. There are many students, those who have not taken maths. So how will they know all these things? So very simple, just join center of curvature to the point of incidence, or vice versa, that is join point of incidence to the center of curvature. So I'm doing that. So joining center of curvature to the point of incidence, so automatically this line becomes the normal, and this angle between the normal and the incident ray we call it as angle of incidence. Say it is 30 degrees, so now you'll be drawing a reflected ray at an angle of 30 degrees. If it is 40, so reflected angle of reflection also will be 40 degrees. So this is the reflected ray. How a ray of light can be reflected through a convex mirror. Principal axis, center of curvature, pole, everything marked same. Let AB be the incident ray. I told you in the previous diagram also that you just have to join center of curvature and the point of incidence. So that makes the normal. But in this case, remember, when you draw this line, it has to be dotted on the painted side always, because that surface is painted. No ray can enter the painted surface. We just assume that it is going that way. So remember, any ray inside the mirror has to be dotted. So this ray of light after reflection will go in such a way that angle of I should be equal to angle R. Next term and very important term we are going to learn is focus and focal length, also called as principal focus because it lies on principal axis, that is why. So I'll explain you first for concave mirror. Everything else same, center of curvature, pole, and I have taken this distance as 4 centimeters. So even when you are going to draw, take it as 4 centimeters. Many rays are incident on this surface. Out of that, I'm going to show you two rays which are parallel to the principal axis. This is the first one. So let me draw the normal. If you remember, I told you join center of curvature to the point of incidence, and this ray of light after reflection moves towards the principal axis. Similarly, another parallel ray to the principal axis after reflection, it moves towards the principal axis. These both rays meet at a point, and this point is called as principal focus or simply focus. The rays are actually meeting, hence we can also call it as real focus. The rays are really meeting, and this point is denoted by capital F, and the distance from the pole and the focus is called as focal length, and that is denoted by small f. So small f stands for focal length, that is distance fp or pf, and if you measure this, it will be approximately around 2 centimeters. So what can I conclude from that? That PC was 4 centimeters and PF is 2 centimeters. So that means radius of curvature is always double the focal length, or focal length is half the radius of curvature. Now let's draw the focal length for convex lens. Everything else same, principal axis, mark C, pole 4 centimeters. So two incident rays parallel to principal axis, and if I join center of curvature to the point of incidence, I will get the normal. So this blue dotted line you can see is the normal. So based on that, one more ray I'll draw. So this is the normal. So the reflected ray will be, now as I was telling you, that any ray or any line which will be drawing inside the mirror has to be dotted. So this ray of light is reflected this way, and one more. So they don't meet, they are diverging. They move away from the principal axis. So but we have back produced these rays and we call it as, they appear to meet at point F, and that is called as focus. Same way length PF is called as principal focus, and length PC, which is radius of curvature, will be double of principal focus. So whatever terms we have studied till now, so let us go through the definitions of these terms. The first one, center of curvature. The center of curvature is the center of sphere of which the mirror is made up of. Similarly, radius of curvature we call the radius of the sphere, which is in this topic we call it as radius of curvature. Pole, the geometric center of the spherical surface of mirror, is called the pole of mirror. It is the center of the mirror, not of the entire sphere, okay? Center of the mirror, and it should be on the principal axis. Aperture, the plane surface area of the mirror through which the light rays enter and fall on the mirror is called as aperture. The horizontal line passing through the center of curvature and pole is called as principal axis. Focus, now two focus definitions, one for concave and one for convex. Focus of concave mirror is the point on principal axis through which the light rays incident parallel to the principal axis after reflection, they meet at this point, and that point is called as principal focus. They are actually meeting, whereas in case of convex mirror they appear to meet. Hence, if you can see, I have written the light rays incident parallel to the principal axis appear to come after reflection from the mirror. So they appear to meet because we are back producing them. Focal plane, a plane passing through the focus, a perpendicular plane passing through the focus. So that's why we have used the word normal. Normal means perpendicular. A plane passing through the focus and normal to the principal axis of mirror is called as focal plane. Now we are going to draw the ray diagrams, but before that we should know certain rules, like certain rays, which rays are supposed to be drawn. So we call it as, either we can call it as rules to draw the ray diagrams, or very simply we can also call it as convenient rays for the construction of ray diagrams. So let us start with a concave mirror. Everything else same, principal axis, mark every point at a distance of 2 centimeters from the pole. That means PF should be 2 centimeters and PC should be 4 centimeters, or FC should be 2 centimeters. So this will be same for each and every diagram. Henceforth, what we are going to draw. So the first ray which you are going to draw is a ray parallel to principal axis. The rule says that any ray which is parallel to principal axis after reflection has to pass through focus. So this is the way it is supposed to go, supposed to be reflected. It has to pass through focus. This was in case of concave mirror. Similarly, in case of convex mirror also. Everything else same, marking the principal axis P, F, C, 2 centimeters each. Now, incident ray parallel to principal axis after reflection, how will this pass through the focus? Because focus is now inside the mirror, it is inside the painted surface. So, here also it is going to pass through focus, but we don't call it as passing through focus, we call it as it appears to pass through focus. So that is why if you have a look carefully, we have drawn the ray which is inside the mirror as a dotted line. Remember I told you that whenever anything, any line you're going to draw inside the mirror has to be a dotted line. So if I summarize this, we can write it as an incident ray parallel to principal axis after reflection passes through focus or appears to pass through focus. So passes through focus we are using for concave mirror, whereas appears to pass through focus we are using it for convex mirror. So whatever rule number 1 we saw just, or the convenient ray, the first ray which we saw, that was parallel to principal axis. In this case, opposite of that. Any ray passing through focus after reflection, how will it go? It will go parallel to the principal axis. Similarly, in case of convex mirror, any ray passing through focus, but here it cannot pass through focus because focus is inside the mirror. So that is the reason we draw it as dotted. So any ray passing through focus or appears to pass through focus after reflection will go parallel to the principal axis. So that is the rule. Any incident ray passing through focus after reflection goes parallel to the principal axis. Rule number 3, the best of all, because everywhere you have to draw incident ray and the reflected ray, but in this case you don't have to draw the reflected ray, because when the ray of light passes through center of curvature, that is the normal itself, angle of incidence is 0, so angle of reflection also will be 0, hence the ray of light goes back along the same path. You can see that arrow blinking. So only one ray, and it's the best ray because the diagrams look neat. So minimum rays and best neatness. Similarly, in case of convex mirror, any ray passing through center of curvature, so that is why dotted, because it is inside the painted surface. How will it go back? It will go back along the same path. So if I write this in words, any incident ray passing through the center of curvature is reflected back along the same path. So 3 rays are done. The 4th ray, any ray passing through pole or incident at pole, to be very precise. If you have a look, I told you, if I join the point of incidence, in this case the point of incidence is pole, and if I join that to the center of curvature, that is the normal, or we can say that principal axis is the normal. So whatever angle is made between the incident ray and the principal axis, along the same angle the ray is reflected. Same will be in the case of convex mirror. So any ray incident at pole, principal axis behaves as the normal and it is reflected in this way. So any ray incident at pole is reflected in such a way that principal axis is the normal. So finally we are going to draw the ray diagrams. First we are going to deal with concave mirror. So the heading which you are going to give is ray diagrams for the formation of image in a concave mirror. Till now whatever we have drawn, there was no image formation. So now we are going to form an image, and all the diagrams, we are going to draw 7 diagrams for concave mirror. So ray diagrams for formation of image in a concave mirror. So the first diagram that we are going to draw for concave mirror, object at infinity, meaning the object is very far away. Say for example, I want to draw the image of sun, I want to draw the image of stars, moon, or a tree outside your building. It is very far away, so we call it as object at infinity. So draw the concave mirror, principal axis, center of curvature. Take the distance 2 centimeters each, PF 2 centimeters, FC 2 centimeters, and then now I'm drawing two rays parallel to principal axis. So this is the incident ray parallel to principal axis. What is the rule? After reflection has to pass through focus. So this blue dotted line is the normal, correct? So this ray passes through focus. Similarly, I will draw one more ray. This ray also is parallel to principal axis, hence after reflection it will pass through focus. Now if you have a look carefully, the image is formed where these rays actually meet. These rays really meet, and the image is formed is just a dot. Hence, let me write first the characteristics of image, the position of image. Image is formed at focus. What about the nature? It is real. Why we call it as real image? Because the rays are really meeting, actually intersecting, and real images are always inverted. So the image formed is real, inverted. And what about the size? Very small, very tiny. The sun's that huge, you have just drawn a dot on your paper. So we write it as the image is highly diminished to a point, just to a point. Second diagram, object still not on your paper. It is say outside the paper. So we write it as object. Still it is not on your paper. We call it as object at a far distance. Everything else same. Be ready with your principal axis, mirror, draw with the help of compass. Remember that. You're not supposed to draw freehand. So first ray I'm drawing passing or incident at the pole. If you remember the rule, any ray incident at pole after reflection, how will it go? The principal axis behaves as the normal, so making equal angles with respect to principal axis. This ray is reflected. Second ray I'm drawing passing through focus. So any ray passing through focus after reflection will go parallel to the principal axis, and wherever these two rays meet this point, and that point where image is formed. So let me draw the image. This is the image which is again diminished, but not diminished to a point as compared to the previous diagram. It has some size little bit, but the position is same. The image is formed at F. We write it as at focal plane. It is real. Rays are really meeting. Immediately write real. Real ke saath the image is always inverted and the size is highly diminished. Third ray diagram, that is object. Now finally it is on your paper. So be ready with your mirrors, drawing all the points. So object beyond center of curvature. You have to always start measuring from P. You should move towards your left. So the object, this is the object I've drawn, which is beyond C. C से आगे. So you are looking from P to C के आगे है object उसके बहुत. Okay. So that we call it as beyond center of curvature. First ray I'm drawing is parallel to the principal axis. Rules are rules, please follow them. It has to pass through focus, passing through focus. Second ray I'm drawing through center of curvature. It will be reflected back along the same path, and wherever they intersect, that is the formation of image. So this image is formed between C and F. So let me write the characteristics. Position, first of all, image is formed between F and C or C and F. It is real, inverted, and look at the size with respect to the object. It is still smaller, so we write it as it is diminished. This time we don't write it as highly diminished. We write it as just diminished. The fourth diagram is object at center of curvature, that is at C. So if I place the object over here, first ray I'm drawing is parallel to principal axis. Any ray parallel to principal axis after reflection will pass through focus. So let us draw that. Second ray I'm passing through focus. So after reflection, that will go parallel to the principal axis. Wherever they intersect, that point of intersection, image is formed exactly of same size. So image is formed at C. It is real, inverted, and of same size. Fifth ray diagram, we are moving object slowly and steadily closer to the mirror. Now it is between C and F. So here is the object. Anywhere you can draw between C and F. Same way, any ray parallel to principal axis has to pass through focus. Second ray I'm passing through focus. It will be parallel to the principal axis. So wherever they intersect, the image is formed. Now if you have a look carefully, the image is slightly bigger than the object. So image is formed beyond C. It is real, inverted, and a little bit larger. So we write it as magnified. Sixth ray diagram, object at F, at principal focus. So if I draw the object at focus, rules, I'll be using the same parallel. Incident ray has to pass through focus after reflection. Second ray, I'm this time drawing through center of curvature. So these rays, they will meet, but outside your book. So outside your book means what? What do we call it as? At infinity, beyond C, बहुत दूर जाके मिलेंगे. So the image is formed beyond C, or you can also write it as infinity, and it is real, inverted, but the size will be very large, so highly magnified. The last position, that is object between F and P, the most important of all the diagrams. You will realize why. So here is the object placed between F and P. Any ray parallel has to pass through focus. Second ray I'm drawing through center of curvature will be reflected back along the same path. These rays will never meet. They are diverging, going away from each other. So we have to back produce them to meet. So let me back produce this ray and the second ray also. So they meet, yes, but we call it as they appear to meet. Why dotted lines? Because it is on the painted side, and here is the image. Once again, reminding you all that anything on the painted side has to be dotted. Even the image has to be dotted. So the image formed is not formed after the actual intersection of the rays. We have back produced them, hence we call it as virtual image. It is bigger than the size of the object. We call it as magnified. So let me write the characteristics. Image is formed behind the mirror. It is virtual. Virtual images are always upright, or you can also write it as erect, and it is magnified. And please mark this diagram, very important. So out of 7 diagrams, this is the most important diagram. Don't forget to mark it important. Now, ray diagrams for the formation of image by convex mirrors. So we have to draw again 7. No, there is only one diagram for convex mirror. Why only one? You will realize. Let's check. So here is the position of F, P, C. Okay. Now, if you have a look carefully at your previous diagrams, object was placed beyond C, at F, between F and C, between F and P. How will we place the object over here between these points or on these points? Because they are inside the mirror, they are on the painted side. So there is only one position where you can place the object, and that is anywhere in front of the mirror. So that is why only one ray diagram. So object placed in front of mirror, rule same. Any ray parallel has to pass through focus, dotted inside the mirror. Second ray, I'm passing it through C. It will be reflected back along the same path. So wherever they appear to meet, that is this point, I'll be drawing a diminished image, but it has to be dotted again because it is virtual. So let's write the characteristics. Image is formed between P and F. It is virtual, upright, and diminished.